Welcome to my zero budget basement film studio. Thank you for joining me. We will together learn the theory of computation from the comfort of my own home. I hope that while you're watching these videos you can be able to pay attention in the same way that you would during class. I know most of you pay attention during class. Try to find a time where you will be relatively free of distractions. I hope you will, try and take notes just the same way that you would in class. That's my suggestion, at least. Of course, you can come back and watch the video whenever you want, but I think you will probably learn best if you just try as much as possible to replicate the learning experiences that you are typically used to. Anyway, we'll make the best of it. I'm gonna make these videos. Probably each video will be shorter than a typical class meeting, because a class meeting, has people ask me questions. I tell stupid stories. I have problems for you all to try out. So I will every so often give you things for you all to try out. I hope that you will actually, pause the video, try and do it, and see how it goes. Of course, you're not able to ask me questions during the video, but I'm going to have office hours. Feel free to comment below, like and subscribe. I will respond to your comments, although it may be better to email me or something else. But, well, let's just do it. So we are going to talk about stack machines. That's something we just started talking about maybe the 5 minutes at the end of the previous class, before the break began, before this disaster befell us. So let's get back to it. I'm going to refresh our memory. Let's talk about that example that we did during class. So a stack machine consists of a bunch of instructions about reading from the input, and then there's a pop and a push operation that happen. Here's the example we did last time. Too high. Sorry. All right. You always got this read, pop, push. Those are the things. And this example is like so. All right, remember what this means is as you are reading the string, you go one letter at a time from left to right, and it says if I read A, we can pop S from the stack and push SX. That means if S is on the top of the stack, we can remove that and replace it with SX. And if we are reading a B from the input string, and X is on the top of the stack, we can remove the X from the top of the stack and replace it with nothing. That's what the epsilon means. And also, the third rule is if we want, at any time, we can do nothing to the input string, pop a S off the top of the stack, and replace it with nothing. All right, those are the rules. And let's just ask ourselves, how about A, B, B, that's not what I meant. Is A, B, B accepted? Remember what that means is if you begin with the stack having just the S on it, when you start the computation, the stack begins with just S. And when I say, is that accepted? What I mean is, can you start with just S on the stack and read this whole string and end up with an empty stack? So what I want to see is the stack being empty at the end, and that means that it is accepted if the stack can be empty. And here's how we wrote down this example last time. So I'm going to make another sort of little chart here. The input string begins AABB, and then the stack begins S, right? This is how you always start. You start with the stack having S, and then whatever string you're trying to see if it's accepted or not. And we are going to read this one letter at a time, do these rules on the stack, and see if we can end up with an empty stack. If we end up with an empty stack, then the string is accepted. So I didn't do anything right here. What happens if I read the first letter, which is an A, so I'm going to underline the one that I'm reading at that moment. We read this A. It says when you read A, you pop S, and replace it with SX. So I am going to throw away this S and replace it with SX. And the stack now looks like that. It has SX. All right, and this sometimes, if you want to label your steps here, call these steps 1, 2, 3. What I did in this step was rule number 1, right? I didn't do it. This is just where you start, so there was no rule for that one. Okay, next I read the next A. So now I'm going to write A, B, B like this. I'm underlining this A to indicate that this is the A that I'm reading at this point. And when you read an A, I'm going to do rule number 1 again. I throw away the S on the front of the stack and then push back SX on the front of the stack. So now it says SXX, all right? Remember, the stack only changes on the left side. The left side is like the top of the stack. So what I did was I threw away this S from the top of the stack. That's the pop. And then I push SX. That means I replace, the old S with the new SX. Okay, that was rule number 1 again. All right, the next letter is a B. Now, my rule about reading a B says if you read a B, you can pop X off the top of the stack and push epsilon. But there is no X on the top of the stack here, right? The top of the stack is a S. So we cannot do rule number 2 at this point. I suppose the only thing we can do is rule number 3, which is the epsilon move. So I'm going to not change anything about the input string, but I'm going to pop S and replace it with nothing. So now the stack is just going to say XX, and that was rule number 3. All right. Now we can actually read B and do the rule number 2, right? Rule number 2 says you read B, you pop X, so I'm going to throw away one of these X's and replace it with nothing. So it's going to say A, B, B like this. Now reading this B, I throw away that X. What's remaining is the other X. That was rule number 2 that I did. And then I can read the next B by doing rule 2 again. What remains here is epsilon. And we're done. We read the whole string and we ended up with epsilon. So A, B, B is accepted. All right, that's how we do it. This marker. Maybe I gotta push harder. Yes, part of my squeaks. All right. This is how a stack machine works. Now, we talked about this example in class at the end last time, and we ended up deciding that the language of this machine, this accepts, come on now, any string like A to the N, B to the N. That's because if you think about how this computation works as you go, every time you read an A at the beginning, you're going to stick on another X onto the stack, right? It also keeps this S on the front. So you can think of the S on the front indicating like I'm still reading a bunch of A's. And as you go, every time you read an A, you stick another X onto the stack. And then at some point, you stop reading A's, you throw away the S, and then you read the B's, and each B kills one of the X's on the stack. And you will get down to an empty stack only when you had the same number of A's as you have B's, right? The same number of A's on the front as you had B's on the end. And so that's why this is going to accept any string like A to the N, B to the N. If you had different numbers here, either you will have too many X's, like if there were more A's, you would have X's left over. If you had more B's, then you would get down to an empty stack before you had read the whole string. So that's why this the language of this stack machine is A to the N, B to the N. Now this actually is not the way that we are typically going to write this. This is a little cumbersome the way that I wrote this in 2 columns here. The book uses a different notation, which I think is a little bit nicer. Let's check that out. I'm going to keep this stuff here so we can refer to it, but so what I'm about to describe is just another way of writing the same thing. I'm going to try a different marker here. All right, rather than this kind of 2-column thing, which is, I mean, it works fine, but there's a nicer way to write it. We are going to write each of these 2 things as pairs. So we're going to start like this, A, B, B, comma, S. So the first thing in the pair is the string which you're reading. The second thing in the pair is what is on the stack. The difference here is I'm not going to put these little underlines here to indicate what I'm reading. As we do this, the first thing in the pair is always going to represent the part of the string which remains yet to be read. So at the point when we start, this is the entire string has not yet been read. All right, when I do the first step, we're going to read the first A and then change the stack to SX. And the way this is written in the book is one of those guys and then ABB, comma, SX. So I read the first A, and so I'm not going to write it anymore. And now this represents the string remaining to be read is now ABB, and the stack now says SX. And then in the next step, we read another A. Now the string remaining to be read is BB, and the stack says SXX. And if you want to label the steps, the book actually does this too. This little arrow here, they put a little 1 down there and a little 1 down here to indicate I'm using step 1 in that little arrow. I don't know what this arrow is called. It's an arrow with like a little peg on one side of it. All right, let's just keep going here. I'm just writing the same stuff here, only in a different way, which is a little more convenient. So the next thing we did was an epsilon rule 3. So we do not change the input string. I'm doing rule 3. Input string still says BB, and then I throw away this X. It looks like XX. All right, and now I do rule number 2. Read B, 2. Reads one of those B's and throws away one of those X's. And then finally I do rule number 2 last time. Come on. Epsilon, epsilon, right? I threw away, or I read the last B, so what remains to be read is now epsilon. And then the stack has also become epsilon. All right? So this is the way that we are always going to write this stack machine derivations. We're not typically going to write it this way. And you can see what's nice about this is we always, let me just say, always start with, you know, sort of your string here, comma S, and then to actually shake it, to actually be accepted. So it's accepted if we can get to epsilon, comma, epsilon, right? That's what you're looking for. The first epsilon means you read the whole input string, and then the second epsilon means the stack ends up being empty, which was what you need in order for the string to be accepted. All right, let's try another one. All right, I'm going to put the rules up here. Read, pop, push. Come on now. So I can read, in this case, read A, pop S, push X. Read B, pop X, push Y. Read B, pop Y, push S. And read epsilon, pop S, push epsilon. I hope you don't mind that I have two different rows with a read B on them. That's going to happen. It just means that if you want to read a B, you have 2 possible things that you could do in that scenario. No big deal. Let's give numbers to this. So these are rules 1, 2, 3, 4. All right. I just want to think about what kinds of things. Oh, come on. What kind of things are accepted or not by this stack machine? Let's try. You know, when you just look at this, it's not really very possible to tell. You really have to try some examples and play around with it to figure out what kinds of things are accepted or not. Let's try ABB, all right? So I'm going to go ABB. We always begin with our string to test out and then followed by S on the stack. What do? Well, I suppose you have 2 choices here. We could do rule number 1, which is what immediately comes to my mind. You read the A, you pop the S, there is an S there, and then you push X onto the stack. Or I could do rule number 4, actually, which is an epsilon transition, which doesn't read anything here, pops the S off the stack, and then puts epsilon back on the stack. Actually, and you know, you can do either one. I feel like rule number 4 is not really going to get us very far because it will make the stack empty, but we're not ready for the stack to be empty. You know, eventually you want to get down to epsilon, comma, epsilon, but at this point I don't want to immediately make the stack empty because I still have to read the whole string here. So I'm going to do rule number 1. So I'm doing rule number 1. We read the A, That means in this string, I'm going to throw away this A because this string represents the part of the string that remains to be read. So it's going to say BB like that. And then S, it says pop the S from the stack. So we throw this S away and push X. So we're going to put X right there. All right. So now it says BBX. Okay. Okay. Let's continue. I guess we're going to have to do either rule 2 or rule 3. Or I suppose you can always do the epsilon, but for the same reasons before, actually, that's not true. We cannot do the epsilon at this stage because you need to pop S off the stack, right? And the stack doesn't have an S, so actually we can't do rule number 4. It's got to be 2 or 3, and for the same reason, the stack has an X on it. We must do rule 2. There's nothing else that we can do here. So I'm going to do rule 2 here. I read a B, so in the first part of this thing, instead of BB, it's now just going to be a single B, because I read the B. And then the X, on the stack it says pop X, so I throw this X away, and then push Y, so I put a Y there. So it's like that, B, comma, Y. All right? At this point, I think, again, there's only one thing we can do. It is rule number 3. We read the B there, and we get epsilon in the front. We pop the Y, replace it with an S, so it's now epsilon, comma, S. And ordinarily you should feel a little nervous about this because I have epsilon here, but it's not epsilon. You want epsilon both places, but actually in this example, we can finally use rule number 4 here, right? Pop, read epsilon, so this remains as an epsilon in the front here, but then we're going to pop S, so throw this S away, replace it with epsilon. It's just epsilon, comma, epsilon, and that means it is accepted. Yes, accepted. I'm going to try a different marker. These ones are not treating me well. Ooh, that one, I'm feeling. Oh no. All right, we'll see. Okay, so A, B, B is accepted. Let's try another one. How about A, B? Can we try that one? Let's just see if we can do this right here. A, B, comma, S. This is like a serious, thick marker. All right, A, B, comma, S. Let's see if we can do it. The thing is, can we get down to epsilon, comma, epsilon? If so, it's accepted. If there's no way to get to epsilon, comma, epsilon, then it must be rejected. So what can we do here? Well, again, we could do the epsilon immediately, but that will empty out the stack and then we'll be stuck. So we're not going to do rule number 4. You don't want to prematurely empty the stack. So I'm going to do rule number 1, and that reads the first A. So now instead of AAB, it's just going to be AB, and then I pop the S and replace it with an X. So now it's AB, comma, X, right? And I think now we're stuck, right? At this point, if you you need to read the A, but there is not an X on the stack. It's an X now, and you can't do rule number 1. Of course, you can't do 2 or 3 because they require reading the B next, and you also can't do number 4 because again, there's not an X. There's an X on the stack, not an S, right? So actually, this is stuck. Now, maybe it's stuck because I did a bad move earlier, but actually doing the other move, you could have done rule number 4 in the first step. That also would have made you stuck. So in this case, we conclude AAB is rejected. All right, is this marker better? I don't know. I have to write giant. It probably is easier to see though. Okay, so in this example, ABB was accepted. AAB is rejected. Is there any way we could think about what kinds of things are accepted by this stack machine? In most examples, it's actually not very easy to see. I think the one that we did first a few minutes ago was a little easier than this. One thing that I will have you notice in this example is that the stack always, think about this, the stack here, no matter which moves you do, this stack will always have just a single thing on it, right? It begins with an S, which is a single letter, and then you can replace the S by an X. If it had an X, you can replace it with a Y. If it had a Y, you can replace it with an S. And then this, I think of this as kind of a special rule. If it's just an S, you can throw it away and then end immediately. But thinking about these three rules here, really, the stack in this particular example can never become long, right? It's just S or X or Y. So actually, in this case, and this is one of the things that you're going to learn to recognize, in this case, this stack machine is actually the same as an NFA, where that stack, which just has one thing on it, you can just think of that stack as representing the state. These three things, S, X, and Y, you can just think of them as three different possible states. And that stack just switches from one of them to another. It doesn't ever get long or more complicated. It's either an X or a Y or a S. So this thing is actually the same as an NFA with three states. Sorry, I don't know if that arrow is really there. The three states are S, X, and Y. And apparently S is the starting state, right? I suppose that makes sense. S is also the accepting state. In order to finish the computation, you have to do rule 4 at the end to finally clear the stack out. So in this case, S is accepting. And then these rules, rule number 1 says if you read an A and you're then that makes you go from an S to an X. So there's the A like that. And rule 2 says if you read a B, it makes you go from an X to a Y. So it's like that. And rule number 3 says if you read a B, it makes you go from Y to S. So that's one like that, all right? So this is usually not possible, but for a special type of stack machine, that is a stack machine in which the stack is always only one letter long, you can always translate it into an NFA. And now when you're looking at this, I think it is clear to say what the language of this is. The empty string would be accepted, and then you can go around this loop as many times as you like. As a regular expression, this is just A, B, B star, right? So it's any multiple of this. So the language, if you wanted to write it as a set, well, it's just A, B, B to the N, right? That's why I remember when we started with this example, we checked that A, B, B, it was accepted, but A, B was rejected, right? And you can see now why. A, B, B is part of this language, but A, B is not. Yeah, right. So sometimes you can translate a stack machine into an NFA, and we're going to talk more specifically about this. This is a special case of something that we're going to do in more generality in a little bit. All right, I want to do one more example. I'm trying these shaky markers again. I want the people to like and subscribe. All right, in this case, I'm gonna try and do something the other way around. I tell you the language, and you try to make a stack machine which accepts the language. This is, you have to have a little bit of an idea. Anyway, let's see if we can do it. Ooh, that one's looking pretty good. The language, let's say, is just all strings on A, B star, such that the number of A's is equal to the number of B's, but not in any particular order, right? It doesn't have to be A to the N, B to the N. It could be just some mixture of A's and B's. It just has to have the same number of A's as there are B's. Now, what's my idea here? One thing that I might suggest if you're trying to come up with a stack machine to represent a particular language, one way to do this is to write down what kinds of steps you want to be able to do, and then just make a list of all the steps that you wanted to do in order to make your machine. So, for example, here's my basic idea. Let me say this. The stack is going to somehow count on the stack, if we have extra A's or extra B's as we're reading across the stack, all right? So here's my idea. On the stack, a 0 means extra A's, and a 1 means extra B's. All right, so as you're reading the string, you want the number of A's to be the same as the number of B's. If you find yourself having an extra A, you put a 0 on the stack. If you have the same number of A's and B's, then you should clear out the stack because there are no extra anythings. If you have extra B's, then you should put a 1 on the stack. This is the idea. So, for example, this is what I said before, you might want to try and like write down a sample derivation before you even write down what the rules are. Just write down how you want the stack computation to go, and then you can invent the rules that do what you want them to do sort of after the fact. So, for example, if I had a string, how about A, B, 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 A, B, A, comma, S, right? Here's just an example. What if I had this string? This string should be accepted, right? Because it has 4 A's and also 4 B's. So this should be accepted. I want to think about how do we get down to epsilon, comma, epsilon? And what are the kinds of steps which are necessary? And we'll just think about these steps and then write them down in a list at the end. What kinds of steps are necessary? So I'm going to imagine what I want to happen here. I'm going to read this A here, and then it's what's going to remain, after I read the A, what's left is B, 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 A, B, A. So far, all I've read is a A. That counts as an extra A. And so I am going to put a 0 on the front of the stack. Technically what I did here is you have to, on your list of steps for the machine, you have to pop something. So technically what I did is I pop S and I push 0S. So there's going to be one rule on our list of steps that says if you read A, you can pop S and push 0S. All right, next. Next I'm going to read B. Now, this 0 on the stack indicates that I had an extra A, but if I read this B, that should somehow equalize things, right? The first letter I read was A, and then I read B. That's 1A and 1B, which is equal. So the fact that I'm reading a B, but I have a 0 on the stack, the 0 represents an extra A, but I just read a B. What I'm going to do here is B, B, A, B, A, A. So after you read this B, it just cancels that 0, and I have S again. So now cancel is not allowed in a stack machine, but really what I did was I pop the 0, and I push an epsilon, right? You pop 0, we'll throw this 0 away, and you replace it by epsilon. So if you're reading a B and you see a 0 on the stack, you're going to pop the 0 and push epsilon. All right, now what if you're reading a B and you see an S on the stack? The S represents somehow the A's and B's are equalized so far. And if I'm reading a B, then I should push a 1 because this is an extra B at this point. So I'm going to read that B. What remains is BA. Ooh, I messed that up. What remains is BA. BAA. BA, BAA. And I'm going to push a 1 onto the stack because that was an extra B, right? We were equalized in the A's and B's. Then I read an extra B, so I push a 1. All right, read another B, I got to push another 1 because that's a second extra B. So now it's going to say A, B, A, A, 1, 1, S, right? What about this A? This A should cancel one of the extra B's from before. So I want this to now say BAA, comma, 1S, right? So there's going to be a line that says if you read A and you see a 1 on the stack, you pop the 1 and you replace it with epsilon. That's to throw it away. All right. Hey, Mare, what are you doing? There she goes. All right, next I'm going to read this B. I have a 1 here, which indicates there was extra B's. I read a B, I should make another 1 there. So this is now going to say AA, 1, 1S. I had 1 extra B, then I read a B, so now I have 2 extra B's. All right, are we getting anywhere? I think we are. So this 1 represents there was an extra B, but when I read an A, that should cancel the extra B from before. So now the next step should be A, followed by 1S. This A cancels a 1 again. I get epsilon, comma, S. And then I'm going to make a special rule that just says whenever you want, you can throw away the S on the stack as an epsilon transition. And it will finally say epsilon, comma, epsilon. Hey, that's what I wanted. All right, so given that this is the way the derivation is going to go, we have to just write down what are these steps that I wanted to be able to do and make a list out of those steps. It seems to me there are a few different ones that we did here. Here's one. If you read A and you see S on the stack, you should push 0S onto the stack. So maybe I'll call that rule number 1. All right, it's going to say, I don't have room to write it down right now, but you can start writing this if you want. Read A, pop S, push 0S, right? Here was a rule in which I read this B and it said 0s and I replaced it with s. It's going to say read B, pop 0, push epsilon, right? And so on. Let's just make the list here. I can't hold this in my head any longer. I will write down my final answer. All right, I got my read, pop, push here. Now the first rule that I just said was if you read A and there's an S on the stack, you push 0s, right? This is to indicate that you have an extra A. If you read B, the second thing that I said, well, can I just say, actually, there's a rule that I didn't write before, which is the same thing but with a B. So if you read A, you should think of this as like reading A at the beginning, you push 0s. If you read a B, when everything was equal, then you should push a 1s, right? Did I say you should call that rule 2? This is not what I was referring to before as rule 2. The other rule that I was saying is if you read a B and you have a 0 on the stack, you can push an epsilon. This indicates if you had some extra A's, this new B is going to cancel one of the extra A's that you had before. And then similarly for the A, we need a rule like this. If you had extra B's and you see an A, then you should cancel the extra B's from before. All right, what if you read an A and you have a 0? This represents if you're reading an A but there were already extra A's, then there's just a new extra A. So in that case, you need to push 0, 0, right? Because you popped this one. You got rid of one of the zeros, you have to replace it. And then with one more 0. And then similarly with a B. B, 1, 1, 1. And then these are all the rules that you need. There was one special rule that we did at the end just to clear out the stack at the very end, and that's this, epsilon s epsilon. I believe those are all the rules you need for this stack machine. All right? And these are the rules. So if your job is, here's a description of a language, you write down the rules that make this into a stack machine. It's a good strategy. We're going to talk about other ways to do this in the future, but one way to think about it is think about what kind of rules you might need, go through a derivation, and then just write down what the various steps you needed to use were. Write them into a list, and there's your stack machine. All right, I think that'll do it. So, yeah, see you next time. Stay safe. Wash your hands. Check in with your grandma.